Alright, welcome to Solving Systems with Elimination. Now, I don't typically make videos with more than 3 examples. However, this is typically a video that's a topic that's very difficult for students when they're first learning it. So I'm going to try and do 5 different examples, and I would strongly encourage you, don't watch just example 1 and be like, oh, I know this, and turn the video off, okay? I need you to watch at least examples 1, 2, and 3 for you to fully understand this, but I'm going to start this off with a very, very easy intro example. Okay, so what's the first thing we should know about this system of equations? Well, the first thing is that they are both in standard form. Okay, that's really, really key. So they're both in standard form. And to really put a fine point on it, standard form is when you have sum x ax plus sum y by is equal to a constant c. So we have our x and our y, our x and our y all on the same side. Okay, so when they're both in standard form, this is when we use this method called elimination. Now this one's going to be a very, very easy example, because if I just add straight down, because this is something you can do. You can say, okay, I can add my 2 equations straight down when they're both in standard form. And if I were to ask you, what is negative 4x plus 4x, just right here, well, negative 4x plus 4x is actually a 0 pair. It cancels. And what if I were to say, well, what's positive 6y plus negative 4y? And you would say, well, that's 2y. And if I were to say, well, what's 6 plus 10, you would say that that is 16. Okay, pretty easy. And then you all know how to solve this. 2y equals 16. How do we get rid of the 2? Well, we divide both sides by 2. And we see, okay, well, y is equal to 8. Pretty easy. Okay, from here we know that we want to plug it into one of these equations. Unfortunately, neither one of these has a variable by itself. So let's just go ahead and plug it into the top one, okay? So we can say, all right, you know what we really have is negative 4x plus 6y is equal to 6. Notice that I went ahead and replaced my y with a set of parentheses because I actually know what y is. Y is 8. Okay, and from here I just want to solve the rest of this. Okay, we have negative 4x plus 6 times 8 is positive 48 times 6. We can subtract 48 from both sides. And when we do that, we're going to get negative 4x is equal to 6 minus 48 is negative 42. And now we can divide both sides by negative 4. Okay. Now, I don't have a calculator on me, and you can double check me to make sure this is true. But I know that 4 goes into 40 10 times. And then there's going to be a 2 left over, and 2 out of 4 is 1/2. So I could really say this a couple ways. I could say, hey, you know what? A negative divided by negative, we have 10 and 1/2, comma. I could write this as a decimal, which would be 10.5. Or the way that I would really like you to do this is I'd like for you to say, oh yeah, both of these can be divided by 2, so I can reduce this to become 21 over 2. In fact, 21 over 2 is the best answer. So let's write our solution as 21 over 2, comma 8. There we go. Nice and easy. Alright, so trust me, you need to see example 2 because you need to see that this can get a little bit more difficult. Okay, here we are in example 2, and this is where it gets difficult for students. So check this out. If I were to use the elimination method like I did last time, if I were to just start adding straight down, I would have 2x plus negative 4x, which would be negative 2x, and I would have 6y plus negative 8y, which is negative 2y, and 3 plus 10, which is 13. And wait a second, I still have both an x and a y, and that is a real problem because I didn't eliminate anything. It's called the elimination method because we are eliminating, we are canceling, we are terminating something. Okay, so how in the world would I eliminate something here? Well, notice that I have a negative 4x right here, and I want to ask you, just really think about this. What is the opposite? What is the opposite of negative 4x? And hopefully you would say that the opposite of negative 4x is positive 4x. And we know that negative 4x plus 4x is equal to 0. So what I need to do is I need to transform this 2x into a positive 4x. I want you to ask yourself this question. What number could I multiply 2 by? 2 times what number gets me to positive 4? And I can do 2 times 2. Okay. And what happens when I multiply 2 times 2x? Well, 2 times 2x is positive 4x. Hey, that's cool. That's what we were looking for. But if I multiply the 2x, I actually have to multiply everything else in that row. So 2 times 6y is going to be 12y. And 2 times 3, I even multiply on the other side. 2 times 3 is 6. Now it's from here, let's even switch colors one more time, that I take these two equations. So I take my original row 2, and I'm going to call this my manipulated row 1, and now I can add these two things straight down. Okay? Negative 4x plus 4x is actually 0. It's a 0 pair. They cancel. And negative 8y plus 12y is going to be 4y, and 10 plus 6 will give me 16. And from here, this is as straightforward as you would imagine. To get the y by itself, I divide both sides by 4, and I get y equals 16 divided by 4 is 4. From here, I'm quite literally just plugging in. Because I see that this top equation is 2x plus 6y. They're both positive and small numbers. Let's use that. Let's say, okay, we have 2x plus 6y is equal to 3. Okay, and in this case, what is y? Well, y is 4. And from here, I can do 2x plus 6 times 4 is 24. I drop the 3. And then here I just start solving. So minus 24, minus 24, and I now get this. I get 2x equals 3 minus 24 is negative 21. I divide both sides by 2. I get x equals negative 21 over 2, which is super weird because we had a 21 over 2 in our last answer. Of course, it was positive. So let's write our solution as negative 21 over 2, comma, our y value, 4, and there is the solution to our second set of equations. Now, I know that this video is starting to get a little bit longer, and so this is my encouragement to you. If this is too long, pause it. Pause it, come back in a little bit, but really try to watch as many of these examples as you can until you fully understand this. Okay, for example 3, it's a little bit different. I want you to take a look. In our x column, we have 2x and 5x. Now, if I were to ask you, what would get rid of a positive 5x, you would probably say, you know what, the opposite of a positive 5x is actually a negative 5x. But my question to you is, can you multiply 2 by any number to get to 5? And of course, the answer is really no. We don't want to use fractions or decimals if we don't have to. And we don't. So we don't care about the x's. In fact, let's go ahead and talk about the opposite of positive 6y. The opposite of positive 6y is actually going to be negative 6y. And wait a second, here we have a negative 3y. So the question is, can I multiply negative 3 by some number to get to negative 6y? Well, we absolutely can. So I want you to think to yourself, negative 3 times what number gets me to negative 6? One more time, negative 3 times what number gets me to negative 6? And the answer is still going to be 2. 2 times negative 3 will get us to negative 6. Easy. So we're going to do 2 times 2x, which will of course be 4x, and 2 times negative 3y, which is that negative 6y that we were looking for, and 2 times 6, which is 12. Now remember, this is our row 2, this is our manipulated row 1, and I can now add these two rows together. So I say, okay, well, what's 5x plus 4x? And that's 9x. And wait, what's 6y plus negative 6y? And of course, that is my 0 pair, equals, and 6 plus 12 is 18. Notice when my y's canceled out, I know that I did this problem correctly. Okay, well, Here we have 9x equals 18. Let me just move this over a little bit closer. So, okay, I have 9x equals 18. So, well, I divide both sides by 9. And, of course, x equals 2. All right, so x equals 2. And let's go ahead and take any one of these equations. Doesn't matter. Let's use the smaller numbers. So let's write 2x minus 3y is equal to 6. And from here, I can say, okay, well, x is 2, so I plug in 2. And from here, I can say, well, you know what? 2 times 2 is 4, minus 3y is equal to 6. And now we just solve for y. So we can do minus 4, minus 4. All right, and whoop, bring it up here. That zeroes out. I have negative 3y is equal to 6 minus 4 is 2. I divide both sides by negative 3, and I get y equals negative 2 over 3. Well, I want to go ahead and write my solution. We can write it as such, 2 comma negative 2 over 3. Alright, y'all, I told you that we would do 5 examples. For our 4th example, I'm going to show you a special case. And after that, I'm going to take it to example 5, and I'm going to give you just the most difficult problem for example 5 that I could possibly think of. Alright, let's go on to example 4. Okay, in example 4, we have 2x plus 3y equals 6, and we have negative 6x minus 9y is equal to negative 18. Okay, so let's start using our same thought process. What would it take to get rid of or eliminate a negative 6x? Well, the opposite of negative 6x is, in fact, positive 6x. Okay, so my question for you would be, okay, 2 times what number, one more time, 2 times what number could get me to a positive 6x? I could do 2 times 3. Yeah, that'll work. So 3 times 2x is positive 6x, and 3 times 3y is positive 9y, and 3 times 6 is actually positive 18. And now that I know my x's will cancel, I can go ahead and add. Wait a second though. A lot of you are probably noticing something. Look at these 2 rows. Each number is the exact opposite of the other term. So negative 6x plus 6x is a 0 pair. Negative 9y plus 9y is a 0 pair. And negative 18 plus 18 is a 0 pair. And this winds up giving us 0 equals 0. And here's my question to you. Is this a true or false statement? Just take a second yourself. Is it true or false that 0 equals 0? And the answer, of course, is that it is, in fact, true. Okay, because it's true, we know that this means that there are, in fact, infinite solutions. And in fact, the best way to say this is that these 2 lines were actually what we call linear multiples. They were linear multiples. Every number in this second line was in fact just taking the first line and multiplying by negative 3. When that's the case, you have infinite solutions. Alright, y'all. For example 5, I don't expect all of my students have made it this far. If you have, this is going to really, really push you, and I would really encourage you to stick around for the challenge. Okay, for example 5, let's just, right away, let's dive into it. Why is this such a difficult problem? Well, there's no number I can multiply 2 by to get to a negative 3, and there's no number I can multiply 4 by in order to get to a 7, okay? So there's no numbers that exist that we can do this. And so what we are going to do is we are actually going to multiply both equations by a different number. Okay, so in green, the number we're going to multiply them by is each other. So if on the top I have 2x and on the bottom I have 3x, well, I'm going to multiply 2 by the other number that I see by 3. Okay, and on the second equation, because I have the 3 right here and the 2 right there, I'm going to multiply 3 by the other number that I see, which is 2. Now there's one problem. A positive times a positive is a positive, and a positive times a positive is a positive. So I need to make one of these coefficients negative, and it doesn't matter which one. So let's just put it with the 3, why not? Okay, so let's distribute. Negative 3 times 2x is in fact negative 6x. negative 3 times 7 is negative 21y, and negative 3 times 3 is equal to negative 9. Okay, down here in this reddish orange, we have 2 times 3x, which is 6x. Notice these two things are going to cancel now. We have 2 times negative 4, which is negative 8y. And lastly, we have 2 times 5, which is equal to 10. Okay, negative 6x plus 6x is a zero pair. And here, negative 21y and negative 8y is actually negative 29y. And negative 9 plus 10 is in fact 1. And how do I get y by itself? Well, of course, I divide both sides by negative 29. And we're going to get a really weird answer. Y is equal to negative 1 over 29. Now, I say that this is a hard problem. Oh, by the way, pause the video and finish taking your notes. Okay, now that I imagine you have paused the video and taken your notes, let me go ahead and erase this. I'm going to erase everything but that top equation. And this is tricky because when I go to plug this in, remember our initial equation was 2x plus 7 times y equals 3. Well, here my y value is negative 1 over 29. This will be tricky because we'll have to apply our fraction rules. So let's do 2x plus, this is really 7 over 1. Remember my fraction rules, top times top, bottom times bottom. Let's kind of say it like this. Positive 7 times negative 1, positive 7 times negative 1 is actually going to be a negative, so let me erase this plus sign. It's going to be negative 7 over 1 times 29 is 29 equals 3. Okay, in order to solve for x, we have to get rid of this negative 7 over 29, so let's do plus 7 over 29. I can write plus 7 over 29. Now we have a bit of an issue. This 3 cannot be added directly to 7 over 29. So what we'll do is write this as 3 over 1. And remember, what we can do is say, well, 1 times what number gets me to 29? Because I need a common denominator. And of course, 1 times 29. But if I multiply the bottom by 29, we'll have to multiply the top by 29. Okay, well, what's 3 times 29? And that should be 87. Let's see, 3 times 20 is 60. 3 times 9 is 27. Yeah, that's right. And then we have 1 times 29, which is 29. And then, of course, we were adding this with that plus 7 over 29. And now that I have a common denominator, I can add them. And what is 87 plus 7? Well, that's going to be 94 over 29. Okay, let me make my 4s a little bit better. Now from here, this is going to take it one step trickier in that whenever you're working with a fraction, you don't want to divide by 2. You want to multiply by its reciprocal. The reciprocal of 2 over 1 is 1 over 2, so times 1 over 2, and we get this crazy x value of 94 over 29 times 2 is, let's see, 58. And at this point, we can write our final answer. Our final answer will be 94 over 58, comma, negative 1 over 29. Alright? I hope that you stayed to the end and watched all 5 examples. I hope that you took good notes. Good luck on this assignment, and I'll catch you in our next video.